The next compound of sodium is sodium chloride, which is popularly known as common salt. Seawater contains about 2.9% of sodium chloride. And then remember, it is associated with magnesium chloride and calcium chloride. The common salt obtained from seawater consists of mostly sodium chloride and a small amount of magnesium chloride and calcium chloride. These two salts are deliquescent. Sodium chloride is not a deliquescent substance, but these two salts, magnesium chloride and calcium chloride, are deliquescent substances. That makes common salt deliquescent. So if common salt is deliquescent, it is you should not blame sodium chloride. It is because of the presence of magnesium chloride and calcium chloride which makes common salt deliquescent. Sodium chloride otherwise is not a deliquescent solid. Another thing you are supposed to know about sodium chloride is solubility of sodium chloride. Solubility of sodium chloride in water is about 36 grams per 100 grams water at 273 Kelvin. At about 273 Kelvin or 0 degrees Celsius, you can dissolve 36 grams of sodium chloride in 100 grams of water. That is the solubility. And one important point regarding the solubility of sodium chloride in water is this is independent of temperature, almost independent of temperature. The reason is heat of solution of sodium chloride is close to zero. Heat of solution of sodium chloride is close to zero. That is the reason why the solubility is independent of temperature. Now regarding uses of sodium chloride, it is an important electrolyte. Apart from that, it is used in the manufacture of sodium hydroxide, sodium peroxide, and you have seen it is also used in the manufacture of sodium carbonate. These are the commercially important substances which can be prepared from sodium chloride. It can be used in the manufacture of sodium hydroxide. We will be discussing under the next category of compound, next compound of sodium. We will be talking about sodium hydroxide, which is popularly called as caustic soda. Sodium peroxide is another substance which can be manufactured from sodium chloride and sodium carbonate. Of course, sodium bicarbonate, which is in turn obtained from sodium carbonate, can also be prepared from sodium chloride. That's about sodium chloride. So remember, sodium chloride, the major source of sodium chloride is seawater. 2.9%, to the extent of 2.9% it is present in seawater, and it consists of two important impurities, calcium chloride and magnesium chloride, which makes it deliquescent. Its solubility in water is 36 grams per 100 grams at 0 degrees Celsius, and its solubility is almost independent of temperature. That's all about sodium chloride. Let's move on to the next compound of sodium, that is caustic soda, also called as sodium hydroxide, chemically called as sodium hydroxide. The next compound of sodium is sodium hydroxide, popularly called as caustic soda. The name caustic soda is given due to this reason, that it has an ability to dissolve mussels. It dissolves mussels and transforms it into a pasty mass. This property is called as caustic property. Because of this caustic property of the substance, it is called as caustic soda. Let's learn about its preparation of or manufacture of caustic soda. It is obtained from brine. A solution of sodium chloride is called as brine. On electrolysis, you get sodium hydroxide. Apart from this, you also get chlorine as a byproduct, and you also get hydrogen gas. These are the substances obtained during electrolysis of sodium chloride solution, brine solution. Let's look at the process is called as Kastner-Kellner process. Kastner-Kellner process. The speciality of this process is, in this process we make use of mercury as a cathode. Look at the reactions. You know, sodium chloride once dissolved in water will transform it dissociates into Na plus and Cl minus equated ions. It dissociates into Na plus and Cl minus. A graphite rod is used which acts as an anode. Anode is a positive electrode, so Cl minus moves towards anode, it loses electron and transforms into Cl2, which comes out as a gas. This is called as oxidation. Loss of electron is called as oxidation. Negative ions move towards anode, they lose electrons. The loss of electron is called as oxidation. So in any electrolytic process, at anode oxidation takes place, that is loss of electrons takes place. These electrons travel from the external circuit, they reach cathode where reduction takes place. Here we make use of mercury cathode. At mercury cathode, sodium ions move, they take up electrons and transform into, Na plus changes into Na, sodium metal, which forms amalgam with mercury of cathode, you get sodium amalgam. Now, the last step, sodium amalgam then slowly reacts with water. It produces sodium hydroxide, hydrogen gas, and mercury is regenerated. This is how the reaction takes place. Sodium amalgam, sodium reacts violently with water. So by transforming sodium into sodium amalgam, we are able to cut down the reactivity of sodium. Amalgamation is it is a case of dilution of sodium. It causes decrease in the reactivity of sodium. So this is to make the reaction between sodium and water a less violent process, a slow process. So it reacts with water to give sodium hydroxide, mercury is regenerated, hydrogen gas is produced. So these are the reactions involved in the manufacture of sodium hydroxide from brine solution by an electrolytic process called as Kastner-Kellner process. I'll briefly talk about Kastner-Kellner process. It's an electrolytic process involving transformation of sodium chloride into sodium hydroxide electrolytically. The anode is made up of graphite and cathode is mercury, which is a liquid metal. Mercury, because sodium is expected to form at cathode, which will dissolve in mercury and forms an amalgam, which reacts with water slowly to give sodium hydroxide hydrogen gas. That is about manufacture of caustic soda. Let's learn about few properties of caustic soda. Few points regarding properties of sodium hydroxide. It's a white deliquescent solid. Deliquescent means it absorbs moisture from the atmosphere, dissolves in the moisture and forms a saturated solution. It is soluble in water, and remember the dissolution is exothermic. That means it dissolves in water with evolution of heat. Its melting point is close to 300 degrees Celsius. Thermally stable. That's the reason why when we heat, it will not decompose, it will melt. It will melt at a temperature very close to 300 degrees Celsius. It's a strong base. All alkali metal hydroxides are strong bases. Sodium hydroxide is a strong base. Exception is lithium hydroxide, which is a weak base. So sodium hydroxide is expected to react with acids to form salts, sodium salts. For example, it reacts with sulfuric acid to give sodium sulfate and sodium hydrogen sulfate. It reacts with nitric acid to give sodium nitrate. So in its reactions, it can behave as a base. Now, regarding uses of sodium hydroxide. This can be used in the qualitative and quantitative analysis. As a reagent in qualitative and quantitative analysis, it can be used in mercerizing cotton fabric. This will give a smooth texture to the cotton fabric. So these are some important commercial uses of caustic soda. You can as well remove old paint from the surfaces and you can apply a new paint. So it can remove old paint from surfaces. That's another important use of sodium hydroxide or caustic soda. That completes caustic soda. Now we'll talk about biological importance of sodium and potassium. Biological importance of sodium and potassium. Let's now discuss about biological importance of sodium and potassium. Number one is transmission of nerve signals. Na plus and K plus ions are responsible for transmission of nerve signals. Number two, flow of water into the cell is regulated by sodium and potassium ions. Another important function of sodium and potassium ions is they regulate flow of amino acids and glucose across cell membrane. So these are the biological importance. This is the biological importance of sodium ions and potassium ions in organisms. One is transmission of nerve signals. Another one is flow of water into the cell is regulated by Na plus and K plus ions. And see, this is involved in the regulation of blood pressure in human beings and other animals. This is about biological importance of Na plus and K plus.